Um, so some of this I'm just going to kind of repeat from what I posted on Piazza. There are a couple of videos that you should have watched before now. One is that we are, as you know, moving to online classes, and there's a video describing how to use Zoom, so hopefully you've watched that already. There's also a video on concepts for assignment 4, which is due in a week. So you should have watched those already, and this will be part of the cadence for class moving forward. I'm going to try to post things in advance as much as I can so that you can have more time to watch them and we can spend class time on either exercises or whatever. I just suspect this is going to work out better for a couple of reasons. One, some people have a hard time. Maybe they don't have a good internet connection at home where they are, or for some reason they're not really able to join classes time, and so this gives them more of a chance to follow along on time. The other reason is that my hunch is that 75 minutes of a Zoom meeting is going to feel kind of long, maybe longer than being in class will. Maybe not, we'll see. But I was wanting to try to see if I could shift some of the lecturing time to kind of async offline rather than making you listen to me in real time. Also doing it offline, watching videos and stuff like that means that you can increase the speed if you want. You can go back and rewind and listen to something again, that kind of stuff. Pause, you know, take a break. So anyway, that's some of the motivation here for doing that way. There are a couple of other videos that are optional. I didn't say that you should watch these before class, but they might be helpful. So making sure everybody's aware of them. Using office hours, that's all going to work through My Digital Hand. The office hour times are still the same, or at least they're still reflected on the calendar that's on the homepage of the website. And whenever LAs are doing office hours, they will be looking on My Digital Hand for you to raise your hand, and that's how they will invite you. So there's information about that in that video. And then lastly, how to pair program with Zoom. Zoom is just one way to do it, but Zoom maybe is a good way to do it. And this is also kind of the way that the LAs are by default going to be using if they're trying to help you. So it might be good to know how to do that. All right, well, hopefully you've seen all that already through Piazza. Just wanted to mention that briefly in case you hadn't. All right, more announcements. There are new options for final grades. Maybe you're hearing about this for the first time here, maybe you're not, but one of the options that you have is to decide to take this class and any class pass fail. You can decide this as late as August 7th. So there's really no reason to decide this now or to commit to it now, although I think maybe if you commit to it now, you might be able to undo it before August 7th. But really, I would suggest waiting until you see what your final grade is, and then, you know, if you decide that it's not what you want and you'd rather have a pass on your transcript rather than a C or something, then you can make that election later. Apparently, a fail will affect your GPA, but a pass won't. This is something that I've heard and haven't really looked into, so that might be something to look into. Hopefully none of you will fail, but just so that you're aware of that potential. Now, in general, it is possible to have an incomplete as an outcome of a course, and this is a possibility apart from just this semester. And what that usually means is that you haven't finished the course, but it gives you some extra time to finish things up. Now there's a new possibility for a CV incomplete for, I guess, for coronavirus or COVID, and that means you get an extra 3 months beyond what you normally would get for an incomplete to finish up the class. Now, what does that mean in this class, given that we, you know, after it's been more than 2 weeks late, you don't get any credit for assignments and exams happen when they happen. So, you know, what does it mean for this class to take an incomplete? Well, I thought about that, and some of you have been having a hard time with assignment 3, and so I have some new policies to announce. So just to update you on assignment 3, I checked this morning, 23 of you are at or near full credit for assignment 3. Presumably that number will be higher by the end of the day when the deadline has hit. But many of you are struggling, especially with Write W-Tree, despite some of the attempts that I've made to help through the last lecture that I gave before spring break, and pair programming, and Piazza answers and things like this. I think more helpful things on the assignment write-up itself. Some of you are still struggling, and some of you are struggling despite spending a lot of time on this. And I acknowledge that, and I'm sorry for it. I'm sorry that it's been a struggle. I do still want you to complete the assignment, but yeah, so COVID-19 changes have made it harder to get help. It's been kind of an adjustment. So even though I do still want you to finish, I want to adopt a new late policy that's a little bit more lenient. I'm going to make a maximum late penalty of 10%. So for example, if you got your CV grade to kind of defer the assignments for a while, you could submit in July or probably even later than that. I'm not sure when the actual final cutoff would be. And you would still only get a 10% penalty because 10% is the max penalty. Now, I hope for my own sake, I don't have to be dealing with stuff into July and August and whatever in the next semester, as well as for your sake, but that is there for you to use if you need to use it. So, you know, my inconvenience notwithstanding, you should feel free to avail yourself of that. Rather than a 2-week late window in linear scaling, I'm going to shift to a 1-week late window in linear scaling, meaning if you submit just a tiny bit late past the deadline tonight at midnight, you'll get like a fraction of 1% of a late penalty. If you submit like 6 days late, almost that full week, that'd be almost the full 10% penalty. So linear scaling is still active, but the window is 1 week. Okay, any logistical questions on anything I just covered? Raise your hand in Zoom and I will call on you. Okay, I don't see any questions. By the way, LAs, I hope you figured out who is keeping track of the participants and interrupting if I'm failing to see somebody with their hand raised. If you haven't figured that out, maybe have a back channel conversation on Slack to figure out who's keeping an eye on that. Okay. So let's do a poll on what you all should have already watched. Go to poll everywhere, and I'm going to activate poll. Okay, should be active. Okay, I'm going to go ahead and looks like most of you are finished. Let me see here. How can I do this? Nope, that wasn't it. No, that wasn't. Okay, what does head do in Git? It tells you which branch or commit is the active one. What is a branch in Git? Let's see, can I do this? Yeah, there we go. It is a reference to a commit. So a lot of you actually got that wrong. It's a kind of a misnomer. It's a common misconception to think of a branch as a sequence of commits. That's how we often conceptualize it, but that is not actually what a branch is. A reference to a commit. And it's called a ref in Git. Okay. So B is correct. A looks like a kind of the header plus object style that we saw for objects being stored in Git, but a ref is not an object in the object database. It's a separate thing. It's a reference to an object, in particular to commit. Okay, so hopefully you all got that right. And if you watched the video, I hope that was fairly easy for you. Okay, but today I wanted to talk about debugging. Okay, let me switch over here. There we go. Okay, so why talk about debugging now? I had actually originally planned to talk about polymorphism and interfaces at this point. But the more I was digging into assignment 3 with you all, I realized that it might be more helpful to talk about debugging, and this might actually be helpful for assignment 3 and for the other assignments, more than polymorphism and interfaces will be. I think those will be helpful too, those topics, but I think this might actually be more needed. Also, I read a really good book on debugging over the break, so this is how I like to spend my spring break, is to read programming books, sort of, but not really. But no, this is actually a pretty good book. I had heard about it before, and I got a chance to get it. I got it from the UNC library, actually, and it's called Debugging: The 9 Indispensable Rules for Finding Even the Most Elusive Software and Hardware Problems, by David J. I'm going to guess Agans, I'm not real sure. Really good book. I was very impressed with it. It's actually, yeah, just really good rules, really well laid out, full of stories, easy to read. So it's not real technical, hardcore stuff, but it's a fairly accessible read, fairly short, but just really well done. Really good rules in here. So I'm going to be basing a lot of my lecture content on debugging on that book, because I think it's a really good treatment of the material. So yeah, that's what I'll be doing. But some general comments first about debugging. We fumble around when it comes to debugging a lot, but there is a methodical approach, and that's exactly what the book lays out. It's a pretty methodical approach to debugging. Not all bugs need a methodical approach. So a lot of times one of the most common things I run into with Clojure is I will write some code and Clojure will complain that some variable is not defined. I'm sure you've all probably seen that kind of thing. That's a bug, but it's not anything that you need a methodical debugging approach for. You just get the error message. It tells you what you failed to define, and you fix it, and you're off and running. So this is kind of like the big guns for debugging. It's not, you don't have to do this. I wouldn't recommend doing this for every single little bug that you encounter. But just know that this kind of methodical approach exists, And it's really, really helpful whenever you do have a harder bug. Okay. So here are the rules. Hopefully this is big enough to be visible on your screens, on the screen share and everything. We're going to go through each of these in turn, but today I'm really probably only going to get to understanding the system, the very first one. But I'll just read them real quick. Understand the system. 2 is make it fail. 3 is quit thinking and look. 4 is divide and conquer. 5 is change one thing at a time. 6 is keep an audit trail. 7 is check the plug. 8 is get a fresh view. And 9 is if you didn't fix it, it ain't fixed. So you might already start to glean some wisdom from this list. There might be some things in here, just some ideas that this is sparking in your head. That would be a good thing. But we'll talk about each one of these in more detail in turn. Again, probably only going to cover understand the system today. There's a lot there that I think is really foundational and important. Okay, so understanding the system, I wanted to talk about some foundations to begin with. I don't think the book talks about this exactly, but I think it's important to just lay the groundwork. I would say the foundational assumption in programming is that the computer is only doing what it's told. If you're seeing some behavior that's surprising, it's not because the computer is misbehaving. The computer is doing exactly what it's supposed to be doing, and probably you failed to understand what you told the computer to do. Or you intended one thing and actually expressed a different thing. So the computer is usually not the thing at fault when there's a bug. Now, by the way, if something's in bold, probably important. So now, occasionally, very rarely, this isn't true. And that's actually what the check the plug rule is about. So for example, there might be a hardware failure or glitch that's making the computer misbehave and making it not follow its instructions correctly. But even then, there's an even more foundational rule that is always true. And that is that there's a good reason why that happened. And so even in the case of a hardware failure, if you get to the check the plug rule, you might start to ask questions like, well, if I'm still not understanding this bug, maybe there's a hardware failure, maybe there's something else that I've assumed is working and it actually isn't, so let me check those things. But even in the case of a hardware failure, you know, that's why the computer is behaving the way that it's behaving, is because hardware is being glitchy. All right, so there's always a reason. All right, so there's a story. I'm getting these stories from the book. There's a lot of these fun stories in here. So I'm going to just read the story to you from the book. Click and Clack of the Car Talk radio show posed an interesting puzzler. An owner complains that his 1976 Volare, I guess is how you say the name of that car, had trouble starting whenever he and his family went out for a certain flavor of ice cream. They often went to a local ice cream parlor and bought either vanilla, chocolate, or 3-bean tofu mint chipped beef. If they bought vanilla or chocolate, the car started up just fine. If they bought 3-bean tofu mint chipped beef, it would not start right up, but would crank and crank, eventually starting but running terribly. Isn't that weird? So this would be a case when we just pause in the middle of the story and say, there probably have been bugs that you've encountered in programming where you've been like, this makes no sense. There's no way this should be able to happen. But there's always a reason. There's always a good reason why it's doing what it's doing. So to continue the story, the answer to the puzzler was that vanilla and chocolate ice cream, being popular, are pre-packed in quart containers and ready to go. but hardly anyone buys 3 bean tofu mint chipped beef, so that has to be hand packed. And hand packing takes time. Enough time for an old carbureted Volare engine sitting in the early evening summer heat to suffer from vapor lock. So again, there was a good reason why that happened, strange as though it seemed at the outset. So because things are intrinsically reasonable, the most important debugging tool is your mind. I'll say it again because it's really important. The most important debugging tool that you have is your mind. Okay, but what happens in real life whenever we encounter a bug? What are some of the reactions that we tend to have? I actually knew a guy once who, seriously, he would just curse and beat his computer and get angry. Nobody wanted to be around him when he was programming. It was not a pretty picture. He would, yeah, I'm not going to say some of the things that he would say. So it's kind of an extreme example, but more commonly, we do get frustrated with bugs, right? I mean, I've definitely felt frustrated with bugs. But examine this reaction in light of this foundational assumption that the computer is only doing what it's told. There's really no sense in getting frustrated, at least not at the computer. Maybe you get frustrated at yourself. Even that might not be the most productive response, but don't get frustrated at the computer because the computer's just doing what it's told. So a better reaction is, this is happening for a reason. Let's understand what that reason is. And I do want to spend some time on this kind of human side of the equation, because I think that's one of the things that we get blocked by just when the rubber meets the road in terms of when we encounter bugs for real. So I'm going to spend a little bit of time talking about, these kind of psychological, emotional things. Remember that code is for humans. All right. So a typical perspective in that vein is like, just do the computer, do what I mean. Come on, computer, you need to do what I mean. And obviously that's kind of a ridiculous thing to say. Computers are not anything that we can, anyway, meaning doesn't work. We're the ones who have the meaning in our head. We have to express that meaning precisely for the computer to do what we mean and what we say. Another perspective that we might hit sometimes is like, this is really hard. I don't know what's going on. This is so confusing. I must be stupid. I must be an idiot. This is some failure in me to understand, and I'm frustrated with myself and feeling discouraged. And this is a real thing that we encounter, right? I have definitely felt this way. I still feel this way sometimes, even with all these debugging tools and even with the experience that I have. But I want to try to frame a better perspective so that we can, myself included, train ourselves to think in these terms that are more productive and helpful. A better perspective would be, there's a reason why this isn't working, and I don't understand that reason yet. Once I do, I'll understand the system better and be better equipped to deal with future bugs. So let's get started. So in other words, cheesy as it may sound, bugs aren't a waste of time, they're a growth opportunity. And this is something that if you can deeply get, and again, I'm still working on getting this and sort of ingraining this in my way of thinking. If we can deeply get this, we will be better equipped to handle these bugs and take them in stride and just keep moving and make progress on understanding them. Okay, questions so far? Remember that you can raise your hand at any point, and hopefully somebody will notice and interrupt me if I don't notice. Okay, I don't see any raised hands, so I'm going to keep going. Okay, so in this sense, when we encounter a bug, sometimes it pays to be the tortoise. You remember the story of the tortoise and the hare? The moral of the story is that slow and steady wins the race. And in a debugging context, sometimes we can get into a mode where we're just kind of thrashing around, trying different things. We hit Stack Overflow and Google, and we say, we just try to describe a problem. We see something, it proposes a solution to some problem that somebody had that looks like ours. So we quickly try to throw that into the program that we've written, and probably it doesn't work, right? Probably it causes some other problem, or it just doesn't fix the problem that we have encountered. And we're just thrashing around and we're not really getting anywhere. This is the hare. And this often just makes the problem worse. We're adding new complexity to our program. We're adding things that we don't understand into our program and into the system. We're making things worse. And even if we do kind of by accident fix it, you probably didn't learn much. Probably you're like, okay, well, at least that's out of the way. Moving on, let's focus on the next thing. And you're still being the hare and you're not learning. Maybe you can get something across the finish line, but you aren't going to understand very well how it works. So a better response is to be methodical. Be mindful of what you're doing, do one thing at a time, be methodical, be slow and steady. The takeaway here is that sometimes going fast is the slowest way to go, and going slow is the fastest, which is kind of another way of saying sometimes it pays to be methodical. And again, the goal here is to actually understand the system. The goal is to improve your own understanding in your head about what's going on so that you can grow, so that you can improve. And that understanding will pay dividends not only with future bugs, but in your ability to extend the system in various ways because you will understand it. Okay, I want to talk about different kinds of programmers. There's a kind of programmer I like to call a framework jockey. I'm intending this as a bit of a derisive term. A framework jockey knows how to use the framework, and that's about it. So maybe they know they're building web apps and they know how to use Rails, or they know how to use Django, or something like that. And I'm not trying to knock these frameworks. They have their uses. Some people can get along fine with them, and that's fine. But the framework jockey doesn't really understand what the framework is doing. They just know kind of how to use the framework, and that's about it. They can crank out some programs, man. They can fly through that framework as long as things stay on the beaten path and kind of stick to the beaten path. They can crank out some programs and they can fly and be really fast in it. But if things start to get off that beaten path, that can be a real challenge. And a framework jockey might throw up his or her hands and say, I don't know how to do that. No, I can't really go there. That's complicated. And basically it's the idea of like, there be dragons. Like, we're not going to go sailing in the Atlantic Ocean. There be dragons. We don't know. And that's kind of the approach that the framework jockey has. They kind of stay up. I think of this in terms of staying up in the clouds. Like they're living at some level of abstraction, and they don't want to dig deep to understand what foundations they're actually using and building on. So the moral of that story is, don't be a framework jockey. Instead, pursue mastery. So don't just sit on top of the framework and ride it, but pursue mastery.